Now we're going to move on and talk about finding the length of an arc. Okay, you guys have done this in geometry, but we're going to go a little further with it. So, arc length. There are two ways to find it, depending on if your angle that you're given, your central angle, is in radians or if it's in degrees. So, arc length. If your angle, your central angle, if theta is in radians, here's the formula where you want to use. S, your central angle, or your arc length that you're trying to find, would be equal to the radius, so the radius of your circle, multiplied by your central angle, theta. Okay, so let's do an example. Let's say I have a circle. Let's make the radius 5, and let's make our radius, our theta, let's make it equal to pi over 4. Okay, so we're going to plug those pieces of information into the formula, and it will determine what our arc length S is here. So my S would be equal to 5 multiplied by pi over 4, which would be 5 pi over 4 radians. That's the measure of our arc length. Okay, so if we have arc length, if our angle is in degrees, we use a separate formula. Okay, so arc length if our angle theta is in degrees. This formula says that your arc length would be equal to on that last one. Sorry, you guys. This is units, it's not radians. It's measured in units, depending on what the length of your radius is. So if it was inches, you would say inches. Okay? Now I can find. We have pi times the radius times theta, whatever our angle is, divided by 180. Okay? So let's do an example. Draw a bigger circle this time. Let's say my radius this time is 3 inches. And I want to find my arc length S, and let's say that this is a 70-degree angle. Okay? So I'm going to plug the information into my formula. So I would have pi, my arc length would be equal to pi times 3 times 70, that's my angle, over 180. Okay? And do this out on your calculator, and you will probably get a decimal. What is my guesstimation here? Yep. And I got 3.66 as the length of my arc. 3.66 inches. Okay. Now let's do an example problem that we would have to use this to determine something. So let's do example 3 out of your textbook, and we'll find the perimeter of a slice of pizza. So here's my slice of pizza. A rounded crust here. Here's your arc length. Let's say that my pizza is 4 inches. My radius is 4 inches. And let's say that my slice is a 30-degree angle. Not very big. So if this is 4 inches, this is also 4 inches because they're both radii of the circle. Okay, so I'll have to find my length of my arc in order to find the entire perimeter of the slice of my pizza. So in this case, my angle is given in degrees, so I have to use the formula for arc length that if my theta is in degrees. So my S will equal pi times the radius times theta over 180. So I'll plug my information in. I'd have pi times 4 multiplied by 30 over 180. Plug the information in your calculator, and it will give you the answer. And for this one, I get 2.09. Okay, inches. So that's 2.09. So my perimeter is going to be 4 plus 4 plus 2.09 or 10.09 inches. Okay, that's example for perimeter. Now let's talk about example 4, designing a running track. So we're going to talk about a track. I'm just going to call it the track problem. In the track problem, they give you an end of a track. And they talk about, they're just looking at 2 lanes of the track. Okay. And they say this is lane 1 and this is lane 2. Lane 1's further on the inside. Our track has more lanes. I think there are 6 or 8 lanes, so and those would continue out. And it gives you the radii. It says that the inside radius. Okay, so it's from the center of the track to the inside lane. So the inside portion of lane 1 is 33 meters. Okay, for lane 2, it goes from the center of the track to the inside of lane 2, and I'm just going to stem that down. And that is 34 meters. And what they're asking you to find is how much longer is lane 2 than lane 1 around one turn. Okay, so one turn. Wants to know the distance, basically, is what you're trying to find, of how much further is lane 2, people in lane 2, if they have to stay in their lane running, than lane 1. Usually after a certain amount of meters, usually the people in the outside lanes can cut into the first lane. But let's find it. So we're going to use the arc length formula, and let's use the one that's in radians just because it's a more simplistic formula. Okay? So we are going to find the radius. So let's find it. Let's do our lane 1 first. So our S is going to be equal to radius is 33. Now we have to figure out what theta is. And since this is a half a circle, our theta in radians, a half a circle in radians, our angle would be 180 in degrees, but in radians, it's pi. So our arc length for the first person in lane 1 is 33 pi. So this is equal to lane 1. Okay? So let's find the arc length for lane 2. Their radius is 34. It's still pi for the central angle, and so there's the 34 pi. Now I want you to find the difference, so simply you're going to take 34 pi and subtract 33 pi, and you get pi. So, or about 3.14 meters. So if you had to stay in lane 2, you would be running further about 3.14 meters.